Recording is rolling. It is Thursday, August 14th. So, plan for today is to have you guys construct this Geneva drive. Actually, this is probably going to be a 2-day project here. Before I get rolling too far on this, planners. So, how many of you guys know a planner? Who has a planner? Ooh, yeah, you guys are using that planner? Okay. So, yeah, hopefully you guys will get some stuff in there. If you have nothing better to write in your planner at this point in the year, then yeah, just write some stuff that you want to do after school, just to get used to using it, to start getting good habits. Guys, if you do not have a planner by now, I do want you guys to ask your parents to buy you a planner so you can start using it. All right, so Geneva Drive. I think I was showing you guys this a little bit yesterday. Right, this right here. What did you guys say? What did you guys come up with this could be used for?
Clocks.
Yes, clocks. I think it was actually its original purpose, right? Going from this continuous motion on my right hand to this incremental motion on my left hand, right? What else could it show up? Possibly. Yeah, if you're saying if you need any kind of incremental gear motion, I guess. Yeah, yeah, it's like a bicycle chain, I imagine. Yeah, it kind of looks like that, sort of. Well, supposed to say. How about did I tell you guys movie projectors it's used for?
Oh,
Yeah, do you guys have do your parents maybe have VHS tapes lying around? Possibly, I don't know. Right? Like how you turn a roll of film into incremental, like 30 frames per second. That's one of these going on. Where else was this used? Somebody earlier today mentioned something that reminded me of the demo video I have. Let me find it. It's this one right here. So this is a series from the 1970s called Connections. This guy's James Burke. He's a science historian. He's talking about medieval world and technology back in the medieval days. So yeah, oh look at this this watermill here. I mean, if there's a river or a waterfall, might turn that. Right, and they would bring up these gear systems. Hey, does this look kind of like some of these parts, like maybe sort of like a Geneva drive too, right? You need to take that continual rotation motion and turn it into something that's incremental, or they got a like a cam here, like to like pound grain or something. Yeah, look at that. So that could be an application there too. Right, so things like that. All right, so let's get a big picture look at the. Oh, and what materials do you really need? So you have some cardstock, some scissors, some glue. That's all you need to make this. All right, so you guys get to use your spatial skills, think 3 dimensions, get help with your friends. So here, pull this apart and let's get a big picture look. So we have a big picture idea of what we're putting together. All right, so what we got here? I have some kind of base, right? Some kind of baseboard. I got a couple of pegs for axle systems. And look on the other side of these wheels. Okay, I see some pegs here too. Now, guys, do you think that the diameter of this peg and the diameter of this peg are exactly the same?
no.
Ooh, you're right. They would not be. So one has to be a little bit bigger than the other. So do you guys see how? I guess this will be true for both of these. Okay. See how it fits kind of snug, so it's not too tight and it's not too loose. Right, so I can spin it. Okay. Same thing with this one. It'd be not too tight, not too loose. So I can spin this one. You guys get too. Okay. How about okay, I got some pegs in the top here. Now I have 3 pegs on this continually turning wheel. You don't have to have 3 necessarily. You could have 1 or 2 or 3 or 4. Right? So I have 1 in the middle to act as a handle. So now I have a handle. Oops, I have that. Okay. I have 2 circles, obviously. Should point that out. 2 circles. Right. And one of them has some teeth cut into. Looks like this one has 8 teeth and 8 gaps. Again, it doesn't necessarily have to be 8. You could go 6. You could go 10. You probably don't want to do too few. I think if you only had 2 or 3 teeth, it probably wouldn't make it around enough. Right. Oh, and here's another design consideration. I'm thinking way ahead here. But do you guys think that like this axis to this axis, like this spacing right here, you probably want some, but like there's some optimal spacing, axle to axle, right? Like if these wheels were too far apart, then these pegs would never catch these teeth, right? But if they're too close together, I bet the whole thing gets jammed up and it doesn't even turn, right? Like if these are like way too close together, right? So, okay. So there it is, big picture. There's all little parts. So now we just got to put this together. Right? That's one thing I want you guys to get out of a class like this too. I teach you all the laws of the universe, and then now you have all these little laws lying around. How can you these things together and make something of your own? Right? All right. So you guys have a page of cardstock. Right. It should be just like 1.5, maybe 2 pages for this. Right. So I'm gonna cut this in half and fold this in half and get 1/2 as the baseboard, and then take the other half and start cutting some circles into it. Okay. So here, I'll do this with you guys. So we're all doing baby steps here. Okay, so take one of these cardstock pages, get this in half. Okay. Again, one of these halves I'll just use as a baseboard, and the other half well, I'll get some circles, but then also eventually you can make some heads too. So that might be some extra material. Okay. I think this is all I'm gonna need. It's just these 3 half pages. You guys got plenty of cardstock, right? You guys need extra cardstock, let me know, but I think we should be plenty to go. Okay. So you guys got 1 cardstock. Let you guys catch up to this. If you chop 1 in half. Okay. Everybody should have scissors. Okay, in blue. Everybody has scissors in blue and enough cardstock. Okay. If you guys are short on any materials, let me know. A few factors in. Think everybody's all right? All right. All right. So, how about bringing my model back here? How about these wheels? Got a couple of circles. Ooh, I should probably get a couple of circles. That would make sense, right? Get 2 circles. Yeah. Now, how big should I make these? My model here is marked. Ooh, can you guys kind of read that? It's kind of papered over. It says yeah, radius is 5 centimeters. Right. I think I'll stick to that. I mean, this model worked pretty good. Right. Now, well, you guys a little bit of leeway too. So if you want to copy exactly what I'm doing, that's fine. If you want to go off the beaten path and try something a little different, say, hey, I want mine to be a little bigger, a little smaller. I want a different number of teeth, different number of pegs. I'll leave that up to you, exactly what you want to do. But I'm going to more or less copy my model. Okay. So how can I get 5 centimeter radius circles out? And I want 2 of these. Guys, if it's 5 centimeters radius, what's the diameter? 10 centimeters. If I want 2 of those circles, well, let's see how wide is this half page here. Ooh, it's like 21 point something centimeters. Yeah, I think I'll be able to fit 2 circles side by side. You guys think? To make sure it works this way. So I got just a different project class thing. Yeah, it looks like about 14 centimeters that way. Okay, yeah. This will be able to contain 2 circles right here. Okay. Here's what I do so I can make sure I can fit them. I'm gonna make a center line. So here's halfway there. Here's halfway right here. Make myself a center line. Check. Okay. And then where would the centers of these circles be? Well, if I need it to be 5 centimeters radius, this could be the center right here. Be an edge. Then over the 10 centimeter mark. Let's go. How about the 15 centimeter mark and 20? Okay. So I just marked out 5, 10, 15, 20. You guys see I just did that? Every 5 centimeters I put a mark. So 5, 10, 15, 20. Okay. This isn't the only way to make circles, but it's one way to do it. All right. So here's kind of this. All right. Do you guys know what tool maybe an engineer or an architect could use to make a really nice circle, just whip off a circle really fast? A compass. A compass is what I'm thinking. Right. I'm not talking about a magnetic compass that tells you what north is. I'm talking about. Here, I'm trying to pull up a picture. Right. Well, okay. Here, I got one on Amazon. How about that? Okay. I'm talking about. Do you guys see that tool right there? Okay. So what you do is you can plant one of these points on the where the center of the circle would be. Okay. And take the other point and like whip off a circle, go all the way around real fast. Right. So yeah, I might talk more about that in a minute. But now I don't have any of those in class. So how can I get some really nice circles out of them? Okay. Guys, what's the definition of a circle? A circle, all points on a circle are what?
Equidistant to the center.
Exactly. Yeah, equidistant from the center. Yeah, equidistant from the center. Okay. And if I'm going for 5 centimeters radius, could I just do this? Can I start on the center point right here? Maybe put park the 5 centimeter mark right there, and then at the endpoints of a diameter at the 0 and the 10 point, put a couple of points, shift a few degrees at the 0 and the 10. Can I just do that all the way around? It's gonna make a really nice looking circle. Can I do that? Right. Sort of a version of a compass in a way. Yeah. So speaking of a compass too, little side story. My brother was in the Navy for a few years. And one thing they would do is that, well, navigation. Suppose you're out in the middle of the ocean. All you see is water in all directions. Right? And then you see some other ships. And your ship has some speed and direction that it's going, and the other ship has some speed and direction that it's going. And you want to make sure that these ships are not going to crash via one application, or maybe just doing some general navigation. So they would have what are called mode boards, these Navy mode boards. I think it might be short for something, I forget. Right? But these like this big old map, right? And they pull out their compasses and they could whip off some distances really fast. Using a compass. Yeah. So application there. Let's see. Back to what's that look like? Oh yeah! Look at that. See dot 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 all the way around. Looks like a circle. Here, we're just gonna play connect the dots right here. Connect the dots. Get myself a 5 centimeter radius circle. All right. A circle right there. So there's one. You know what? Two. Another side thought I'll mention. Now, my two circles on my model are the same size as each other, and I think I'll just go ahead and do that again today. Okay. But what if they weren't? Because what if one of these circles was really big and the other was really small? Right? If one circle, let's say the big circle turns around one full revolution, right? One full revolution. The little tiny circle would it turn around also one revolution, or more or less than one revolution? More. Might be like 5 or 10 revolutions, depending on the ratio of sizes. Okay. And vice versa. If I was hand powering the small one, I think the big one would turn very slowly. Yeah, so you get like a gear ratio. Ooh, you do that too. Speaking of what I just said, revolutions. Is that one way to measure how far, say, a wheel is turned or how far around a circle can you measure revolutions? Okay. Guys, what's another way you can measure how far have you gone around a circle? Degree. Can you measure in like degrees? Right? Yeah. Degrees? Okay. How many degrees in a circle all the way around?
360.
360. Right. Now, why 360? Guys, where does that number come from? 360. Nobody 100% knows for sure, but there's some speculation. For example, can you guys think of what's a cyclical number that we use on Earth that is pretty close to 360?
365.
Yeah, 365 days in a year, right? It's pretty close, right? That might have something to do with it. Also, guys, what place value system do we use? We use a base what system?
Base 10.
Base 10. What was common back in Babylonia a few thousand years ago? They didn't use base 10. They used base
12.
16? Yeah, I know 60 they used. There may have been some other ones floating around, but I know base 60 was used. Say characters for 0 through 59 before it rounded to the next decimal place, I think. Next place value. So, yeah, I know 60 goes evenly into 360. That might be another reason. I think it's why we still have 60 seconds in a minute till this day. 60 minutes in an hour. Probably falls out of that base 60 system they were using back in Babylonia. But here's a thought I sometimes have too: is what if the aliens come visit us tomorrow? They land a spacecraft on Earth, say we're here, and we start comparing our knowledge. Do you guys think if there's some spacefaring alien civilization comes visit us, do you think they would know what the value of pi is? 3.14, blah blah blah. I mean, probably so. Yeah, probably so. Do you think they know the Pythagorean theorem? Yeah, probably so. Do you think they also divvy their circles into 360 parts? No, probably not. That would be a real freak occurrence because that's really kind of random, isn't it? 360, right? So what's another way to measure how far around a circle you go? If you're not using degrees, you're not using revolutions. What's another way? You think it's
Radians?
radians? Aha! Yeah, you guys heard of radians? Yeah. How many because you guys know it's 360 degrees around a circle. How many radians around a circle is that?
2 pi.
2 pi. Yeah, 2 pi. Right? And if there's some alien civilization that visits us tomorrow, I would say there's a good possibility they'd come up with something pretty similar to that. Like, oh yeah, we know there's 2 pi radians on a circle, right? Because that's more a mathematically pure way to represent how far around a circle. Later in this class, when we get to translating, say, like rotational motion to like back to linear type motion, I have a box of turntables to give you guys some turntables to be spinning. If you want to do a direct calculation like that, you cannot be using degrees because 30 degrees, the number 30 doesn't really represent anything in a pure math form. Right? unless you bring in a sine or a cosine, then it's okay. But because your calculator would be programmed to be able to handle degrees as a convention. Okay. Yeah, if you want to straight multiply an angle to say like, oh, I wonder how far around the circle you've gone in terms of meters, and I know how far it's turned if you're on a giant merry-go-round. Yeah, you cannot use degrees to do that because it doesn't make any sense. But you can use radians. In fact, you guys will a few months from now be using some radians. All right, so here I got a couple of circles cut out. I'm gonna do this. I'm gonna pause this video and walk around the class and check on you guys.
Very.
All right, recording's back on. A lot of you guys are up to here, so we guys are getting pretty close. And so yeah, so I was walking around. Hey, you guys have some pretty creative things going on. Yeah, some guys came up with the method of forgot about this, but there's some string on your desk for the other class I'm doing a different project. So yeah, you can wrap the string around in a loop, right? You have a couple of pins, right? So you can whip off a circle that way, real fast, little compass like. You could. Some guys had the idea to just make one circle and just slap that down and trace it. Zoop, quick circle that way. There's you could have used the ruler maybe as a compass. Forgot about this one too. Got some notes in the ruler. You know, like whip off circle that way. You guys could do. There's yeah. Somebody's had the idea to have different size circles. Ooh, so you have like a gear ratio. Yeah, so that'll be a fun one to see in motion and time. Yeah, so you guys got some good ideas going out there. Okay. So break up the model again. Now, if I copy my model exactly, then how many of these heads do I need? Like, now you guys already told me that these are not going to be the same size, especially these axle pieces. But I got 2 on the base. I got 2 on the underside, so that's 4. And then I got 4 more here, 1 at the handle and 3 pegs. So maybe like 8, I guess. Right? 8. So they all look sort of the same. Again, these are going to be a little bit different size. But how do you think I can make one of these cylinder-looking pegs? How can I do that? Roll up what would start as what you would first cut out of what? Rectangle. Aha! Cut out a rectangle. Right? So let's see if I want. Say 8 of these, right? 8 of these. And if you want to do different number, it's all right. We'll do 8. Okay. See, 8 rectangles. How can I get 8 good rectangles out of this? Well, here, how tall are these? Right. So on my model, they're about 2 centimeters tall each. Right. But that's not all. Because if you look really close, you guys see I cut some feet into these, like 5 feet. Right. So that's maybe another 1 or 2 centimeters. So maybe I want 3 or 4 centimeters tall and so many centimeters wide rectangle. Let's try that. Maybe I'll go 4 by something. Okay. 4 by, well, I don't know. We'll see. I got 4 centimeters. So I'm marking out 4 centimeters from the edge. So there's 4 centimeters there. Now, might need another line of these. So here's another 4 centimeters. Zip. So here's 4 centimeters wide here, and here's another 4 centimeters wide here. Right. And then how long should I make these?
4 centimeters off where?
From the edge. So from here to here, this is 4 centimeters. Okay. So 4 centimeters. Okay. You know what? Maybe just to keep it simple, I'll just cut a bunch of squares so that it's not. There's no question about should I wrap it this way or this way? Because if they're all squares, it'd be the same either way, right? Okay. So let's do. Let's see. If I mark off, there's 4, 4, 4, 4. Okay. So mark 0, 4, 8, 12, 16. Okay. And same thing down here. And go 0, 4, 8, 12, 16. Boom. Right. Okay. There's 8 squares right there. You see those 8 squares? They're all 4 by 4 centimeters. Okay. Let's kind of make this up on the fly, but yeah, this should work. Okay. So I'm going to cut out these 8 squares, and these will eventually turn into cylinders. I can use as pegs. All right, well, pegs and a handle and an axle system. I'm going to get all out of these 8 squares right here. These 8 squares. Here's my 8 squares. All right, cut these out.
We're trying 8 squares.
Yeah, so well, I'm cutting 8 squares. So yeah, if you want to follow exactly what I'm doing, 8 squares here. And these are all 4 by 4, so 4 centimeters by 4 centimeters. So while you guys are catching up to that point, let's do a little bit of scaling here. So think about so from one property to another. Okay. Because if this is 4 centimeters by 4 centimeters, let me go ahead and mark that. So draw it out so you guys can really see. So it's 4 centimeters that way, and then 4 centimeters that way. So 4 by 4. Okay. How many square centimeters would one of these squares be? 16, wouldn't it? 16. Right. I'll draw it out just in case you didn't quite visualize that, and also why you guys are catching up too, because some of you guys are cut some squares, cut some rectangles. Okay. I'll draw this out. Okay, so if it's 4 by 4, yeah, that would be 16, wouldn't it? So, right. Yeah, just like that. Yeah, it's 16 of these 1 centimeter squares. So 1 by 1 is one of those. Yeah, 4 by 4. Yeah, you get 16. Look there. Right. Okay. So I need to wrap these into cylinders. And a good way to do that is, well, if you have a pen or a pencil, or what I'm going to do is pull this apart and wrap this around my ink cartridge. Right? And you just need a little bit of glue. So here, start wrapping this around. Okay. Yeah, so I got this wrapped around. Okay. And then just on this end, now, if you don't have enough glue, then maybe it doesn't glue very well. But if you have too much, then it's going to take a long time to dry. So I'm just going to put an optimal amount. Optimality. Optimality. Okay. Not too little, not too much. Some Goldilocks amount. Get any glue out of this. So put this here. There we go. All right, wrap that around. Okay, so I just put a little bit of glue. An optimal amount. Okay. Wrap that in a cylinder. Now, if you just press and hold that, or do what I'm doing, just go around it a few times for 20 seconds or so, yeah, then you will have a cylinder. Boom. There's one down. So I'm just gonna roll a bunch of cylinders now. Start rolling a bunch of cylinders.
So it's not gonna be it out. Because I didn't want something to do like it so far. I didn't want to do this. I got first. Yeah, there's things. Yeah, no, I haven't seen it. Yeah. Ah. My teacher. And I gotta
I swear, what's the?
I'll put it on your so I say you I used to do this.
Yeah, no, you don't have.
Would you call for the
Do we make all 8 the same size?
Ooh, yeah, guys, should you make all 8 the same size?
I don't think so.
Ooh, no, because here's why. Here's why. Okay. Now if you make most of them the same size, it's probably all right. But guys, when you get to this axle system, here's a good thing to do is take one square and roll it around another cylinder you already made, so that one can fit snugly inside the other. Right, not too tight, not too loose. Right, so this can actually spin. I see how this is free to spin. Right, it's not too tight, not too loose. Yeah. So maybe if you do 8 cylinders like I'm doing, maybe 6 of them can be the same as each other. But the last 2, yeah, you want to make it a little bit looser, a little bit bigger diameter.
First, it's stiff, bro.
And so she something.
I think this first.
There's 6. Yeah, for this last I'm gonna have one cylinder already there. You take another square, wrap it around.
No, they heard me at Walmart, and I was very sad when I came back.
That's so
So
weird.
I had to tell my dad about
I don't know how to.
That's so annoying.
Do it.
Driving that wire, not being able to buy my dog.
Not too tight, not too loose. Need what? Let's see, 1, 2, 3, 4, 5, 6, yeah, at least 6.
There's grabbing it around and dragging it. I just, wait, how do I get this?
No, gorilla. Not speaking.
No, I'm buying logins. I use it on my AirPods.
Wait, I would take. Oh, that's great.
Yeah, you
So I have a bunch of cylinders. Just show you guys this does move like that, right? So see how I have an axle system right here.
Can I please use directions?
I see how I have an axle system, and this other one also axle system right here. We're gonna do it like that. Yeah, that's probably exactly what I'm looking for. All right. So got my baseboard, got a couple circles, have some cylinders, including a couple of axles systems. All right. We go ahead and hit pause on this recording and walk around and check on you guys.
No, we're
So,
not.
back recording. Recording's back going. Let's walk around the room. You guys are doing pretty good. Some of you guys up to here, some of you guys are working towards it. All right. So, so I'm thinking ahead a little bit. Yeah, it's gonna take us also until tomorrow to finish. But I'm thinking ahead a little bit. All right. So I got some cylinders that are gonna act as these pegs and whatnot. Now, a couple of considerations. One is like, how am I gonna get this peg on this circle? Now, maybe there's like good ways and bad ways to do this. Right? How about this? Because suppose you want to glue like an edge of a paper to a surface of a paper. Because if I take this paper right here and I glue it like this, just put a line glue, put this right here. How long would that take to dry? Yeah, probably several hours, and that would be no good. You'd be here all day, just like holding this, waiting for this to dry. Right? But guys, what if you somehow are able to get a surface to surface connection? What if I glue this like this? That probably dry within about 15, 20 seconds. Yeah, which is a lot better. It's really strong too, right? In fact, that's exactly what we've been doing with these cylinders. this is a surface to surface connection on the inside. Surface to surface, like that drives really nice, right? An edge to a surface, ooh, not so good, right? But if I take one of these cylinders and I try to glue it like this, say like for the handle, right? That would be an edge to a surface, wouldn't it? It's probably not going to work so well, right? So, how can I get a surface to surface connection? Huh? What do you guys think? What's the solution? How about cut these feet? You guys see these feet are cut into it? Right. Right. So I show you this. So I can go around and just cut some feet into this. Cut, 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 cut. Right. Spread out these feet. Right. And look at that. Now that I can glue, make a surface to surface connection. Right. You guys think that'll glue a lot better? Like that?
You do this.
Right. Here, I'll do another one. Right, so take this one because I think I need to do that for all of these. So go cut, 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 cut. Let's go around, okay, and then spread these feet out. Hey, it's another set of feet. Look at that. Okay. Okay, and now this will be able to glue really nice right there, surface to surface. You did it. Okay. Okay. Also thinking ahead a little bit because yeah, so. Walking around checking on you guys. Some guys are getting a little ahead, looking towards future steps. Okay. Now, eventually, when this comes together, and a lot of you guys probably get to this step tomorrow, somehow I want these pegs to catch these teeth, right? Like the gaps between these teeth, right? Now, when that eventually comes together, think about this mechanics, that, like from a whole systems point of view. When this peg is leaving this gap between the teeth, isn't it true that the next gap in the teeth has to be lined up to accept the next peg? So it goes like that. Is that true? Right. And then when that peg leaves that gap, the next gap is lined up to accept the next peg. So it can just keep doing that forever. It would go around forever. Right. Now the only way for that to happen is if your teeth are spaced how? Do you want it to be spaced evenly around? Or do you want there to be like a small gap followed by a large gap followed by a small gap? What makes more sense?
People.
Evenly spaced around. Ooh. And guys, what tool would be really nice to have to measure even spacing? A protractor, which I do have a box of protractors. So I will get you guys a protractor here pretty soon. Yeah, protractor. So you can measure angles. Right. Now I have 8 teeth on my model. You probably want at least 6 teeth, right? If you have 2 teeth, that's probably not going to work. But probably 6 or more teeth, it's going to be all right. Okay. Here's another design consideration. Do you think I have to have these spaced axle to axle, some optimal spacing? Too far away, not going to catch. Too close together, gets all jammed. Right. Okay, so these are all little things to think about ahead of time. So this eventually comes together. All right. Yeah, well, I'm going to continue cutting feet and these cylinders. Got some pegs, got a handle, got an axle system going.
How many pegs do we
I had 8. You want at least 6.
need?
Yeah. Because here, let's do a count. So here's my model. If I pull my model apart, for the axle system, looks like I have 2 here and 2 here. That makes 4. That's 4 just to get it to get 2 wheels to spin, right? So 2 on here and 2 on here. Right. Again, those are slightly different sizes so that they fit one side the other. Okay. That's pops back together. Okay, so that'd be like this right here. Right. Actually, this is what they look like in cylinder form. You guys see that axle system? Right. So that's 2, 4. Right. You want at least 1 to act as the handle. So that could be 5 right there. 5 is the handle. And you want at least 1 peg to catch the teeth. So that would be 6. And I have 2 extra ones. So that's why I have 8. Right. Accepted. All right. All right. So here, go back to cutting feet.
All that. Right.
Oh.
I mean,
Why are you already over?
I should use that. I walk. Do we got two pairs of teeth in the one? Back to on you this year.
No, it's not like.
Maybe. Just the one for like.
All right. I'm gonna pause the video, walk around, check on you guys. All right, we're back to court in. Back to court in. Right. So yeah, I was walking around. Yeah, you guys, all you guys do have these protractors around. So I did put these around. So this can measure angles, and it might be really good to measure angles. Say if you want, guys, you by the time you get to cutting teeth in this weird, this tooth wheel, do you want the same number of degrees from tooth to tooth, the same angle?
Yeah.
Yeah, absolutely. So from the center. So if this nodal point of the protractor is right in the center, yeah, you want the same angle. Okay. So if you let's see how you can figure out what the angle is. If you have 8 teeth, and you guys told me earlier, there's 360 degrees in a circle, and the protractor is in degrees. So let's just use degrees. Okay. What method could you use to figure out what angle is between this pair of teeth right here? Exactly. Yeah. Just take 360 degrees and divide by 8 since I have 8 teeth, right? Now, if you want 6 teeth, you could do 360 divided by 6. If you want 7 teeth, you do 360 divided by 7. You guys get the idea? Right? But you know what? We have 2 minutes of class left. 2 minutes. So this is going to be our pause point. We're going to finish this project tomorrow. Guys, go ahead and do this. Write your name on your materials. And I have lots of lab space back there. So find a space to store your project. Make sure your name is on your materials. I will write period 4 on this. Period 4, right? And we'll pick up there tomorrow.